Hello everyone. In the last video we have seen how the quicksort algorithm will work. I have just showed you with an example array. Today we'll see the mathematical analysis of quicksort. I have just told you mathematical analysis means first you have to just find out the general plan and then you have to just find out whether the algorithm will come under best case, worst case or average case. Till now we have seen we were just traversing through all the arrays and then we were just going with average case. In quicksort it is quite different. In quicksort you'll be having all the cases. You'll come up with best case, worst case and average case. I'll just show you how. Here in divide and conquer technique we are dividing the array into two types, but it is not exactly at the middle in case of quicksort, is it not? So here we'll be having an array. If I take an array like I'll be having an array like this, just an example array I'm taking. So here if I'll just consider first element as a pivot element and then we'll be just dividing it. Is it not? Here we'll be just having three cases, that is best case first I'll take. Best case is nothing but here dividing the array exactly at the middle. Okay, so here 1 2 3 4 5 6 7 elements we have. So I'll be just having over here exactly at the middle the array is dividing. In the left side it will be left side of the array and right side of the array will be having the same number of elements. Okay, so this is best case. If I have to just go with the worst case, before going for the worst case I'll just tell you the general relation what we get for this one. Yes, here I'm just dividing the array into two different parts. Totally I'll be just having n elements. I'm just dividing it in the sense this is n by 2 and this is n by 2. Yes, and here how many number of times we are selecting the pivot element? Only once? No, it is n number of times. That also depends on the array. Is it not? The size of the array. So pivot element I'll just consider as n, and two arrays which we have divided, that I'll consider as n by 2 and n by 2. Okay, so how will be the general plan? T of n. For example, if you have only one element, then there is no need of sorting it, is it not? It will be already in sorted order. So no need to do anything. If only one element, it is 0. Otherwise, if it is greater than 1, n is greater than 1. Yes, in such case, you have to divide the array into two equal parts with the help of a pivot element. This n is the pivot element. This is the general plan for this quicksort. Yes, this is only for best case. In this video I'm explaining only about the best case. Next video I'll just go with worst case and average case efficiencies. Okay, so here what I have to do, I'll just will solve this best case. T of n is equals to T of n by 2 plus n plus T of n by 2. This one I can just write it as 2T of n by 2 plus n, because I have 2 T of n by 2, so I'll just write it as 2T of n by 2 plus n. Yes, so the same thing here also, replace n by 2, because in the previous mathematical analysis in this function you were having n minus 1, so I was just replacing it with n minus 1, but here inside the function what I have, so I have n by 2, so I have to replace this with n by 2. Replace n by 2. Next we'll follow the same procedure. Yes, so what is that? T of n. Here 2 is the constant. I'll just keep 2 as it is. Then t of n by 2 is the function. For this, I have to replace this entire thing. Yes, so on replacing 2 t of, for what? N, what I have to do? N by 2 divided by 2. This will become n by 4 plus n divided by 2. Because we replace each and every n by 2. And then again here, this is a constant. I'll consider n as a constant. I'll keep this n as it is. Once again, it is constant. This one, 2 2s are 4 t of n divided by 4. 2 into 2 plus 2 into n by 2. 2 and 2 will get cancelled. I'll be left out with n. And this n, I'll just write over here. Yes, so this one, I can just write it as 4t of n by 4 plus 2n for the next step. Again, replace n by 2. Yes, 4 is the constant. This is the function. T of n by 2 by 4 plus n divided by 4 plus 2n. So this one, yes, sorry, 4 into 2 into t of n by 2 divided by 4 plus n by 4 plus 2n. This one will become 8t of 4 2s are 8 plus 4 and 4 will get cancelled, n plus 2n. 8t of n by 8 plus 3n. If I'm keep on doing it like this, yes, what I'll get? See, initially I had 2, here 4, that is 2 power 2, 8, 2 power 3. So I'll just write it as 2 power I in general, because I'll be just having 2 power 1, 2 power 2, 2 power 3, 2 power 4, like that I'll be just getting. So 2 power I. Same here also. First I had 2 n by 2, then n by 4, n by 8. That is t of n divided by 2 power I plus here 1n, 2n, 3n, 4, 5, 6, like that it will be going I n. I'll take. Yes, so this is how I'll get. So here 2 power I, if I just take 2 power I is equals to n, then with the law I'll get I is equals to log n to base 2. Because if you have I taking log both sides, take log both sides, I'll just take log 2 power I is equals to log n. This one I'll just get it as I into log 2 to base 2 is equals to log n to base 2. So log 2 to base 2 is 1 itself. I is equals to, I'll get log n to base 2. So you have to just replace I by log n to base 2. So wherever I we have, so I have to replace it with log n to base 2. Yes. So what I'll get? Two power log n to base 2 t of n divided by log n to 2 power log n to base 2 plus n into log n to base 2. Here this one and the base, if this is same, then I can just write it as n into T of this one n divided by n, I'll get n into log n to base 2. So this one I can just write it as n into T of 1 plus n into log n to base 2. T of 1. Okay, so see here, n is equals to 1. If n is equals to 1, what is the thing? It is 0. So this entire term will become 0, n into 0. Is it not? So I'll be just left out only with n into log n to base 2. So I can just write it as T of n belongs to, this is best case efficiency. Best case is omega of n into log n to base 2. So the best case efficiency of quicksort algorithm is T of n belongs to omega of n into log n to base 2. Which is the best case? If array is divided exactly into 2 halves, means pivot element is at the middle, left part of the array and right part of the array are having equal elements, then this will comes under best case efficiency. Okay, in the next video I'll just explain what is the situation for worst case efficiency and then what is the situation for average case efficiency, and I'll just show the time complexity of worst case and average case. Okay, thank you. If you have not subscribed, please subscribe to the channel.